my name's Anna Marie Picarello, and for my Chem 2 Extra Topic 1, I'm going to be talking about supercritical fluid. Alright, so supercritical fluid is any substance characterized by a critical point which is obtained at specific conditions of pressure and temperature. When a compound is subjected to a pressure and temperature higher than its critical point, the fluid is said to be supercritical. So this can be shown by the phase diagram over here, where a particular substance is a solid at this temperature and pressure, and a liquid is in these areas, and it's a gas in these areas. And right here is the supercritical point. So right over here, it would be a supercritical fluid. Alright, so I'm going to talk about some of the uses for a supercritical fluid. Depending on the fluid and equipment used, a supercritical fluid can raise technological barriers, optimize the manufacturing process, and provide a sustainable alternative to conventional production methods. So some examples of this are crystallization, drying, polymerization, purification, and there are many more as shown below. Alright, so I'm going to talk about some of the substances that we've found particular uses for in our society. So I'm going to start with supercritical CO2. Alright, carbon dioxide is one of the most widely used supercritical fluids. It is non-toxic, non-flammable, and readily available at low costs. The critical point is also easily accessible, being 31 degrees Celsius and 24 bars in pressure. This allows the fluid to be used at mild temperatures of 40 to 60 degrees Celsius without leaving harmful organic residues. Due to its interesting properties, supercritical CO2 can be described as a green solvent, meaning it's very environmentally friendly. Okay, so another supercritical fluid I want to talk about is supercritical water. So the critical point of water is much higher than that of CO2. However, its applications are very promising and some are in the process of industrialization. Water in the supercritical phase can solubilize hydrophobic compounds. Therefore, it can be used for the extraction of plant materials. Oxidation in subcritical water can also be carried out in order to achieve efficient waste processing. In supercritical water, organic compounds and gases become highly miscible, and precipitation of inorganic compounds occurs. This helps to treat harmful wastes and the synthesis of nanoparticles. These processes are called supercritical water oxidation. Alright, so I'm going to talk about some other critical fluids. So there are many more that we've found use for, such as ethylene, propane, methanol, ethanol, and these are shown over here in the chart, and you can see at what temperatures and pressure they are achieved. Alright, so now I'm going to talk about someone who's made great advances in the field, not necessarily of supercritical fluid, but of alternative fuels and with similar methods. So Frances Arnold is a chemical engineer, Nobel Prize winner, and Princeton graduate. So some of her accomplishments is that she worked as an engineer at the Solar Energy Research Institute in Colorado, Brazil, and South Korea before acquiring her PhD in chemical engineering at the University of California, Berkeley. She then combined her interest in biofuels with the emerging field of biotechnology. Arnold began working on modifying the DNA of enzymes, then inserting them into bacteria, which change the enzymes further until they are optimized to serve as catalysts in the creation of cleaner fuels. Alright, I'm going to talk about her work today. So Arnold's pioneering work using directed evolution to engineer enzymes has been applied not only to biofuels, but also to products as diverse as laundry detergent and contrast agents for MRI scans. As a result, she and her work were recognized with the Nobel Prize in Chemistry in 2018, making Arnold only the 5th woman to win the prize in chemistry and the 17th female Nobel Prize winner in the sciences. So I think this is a really good accomplishment, and it's nice to tie her works to the process of subcritical fluid. And overall, many scientists are working to create safer biofuels and alternative fuels. So yeah, that's my topic for chemistry.